Hello everyone, we're going to talk you about our final project and it is about the spectrographic glucometer. The team is confirmed by Damian, Giovanni, Hector, Said, and me, Luisa. Let's start.
Okay, the table of contents is the third contents, the glucometer parts, the prototype and designs and development, and the results. Okay, the theoretical concepts of glucose meter. A glucose meter is just to measure the amount of glucose in your blood. Is a portable medical device that tests your blood without a finger sample.
Infrared spectrometer. These studies, help study the phenomenon of interaction between infrared radiation and matter. Energy from radiation at an infrared wavelength is absorbed by a molecule vibrating at the same wavelength in its ground state, causing a change in the intensity of the vibration. Operation of a spectrometer. The parts of this one, it has a spotlight that produces the beam of radiation, the analyzer that separates the beam with respect to the properties which they wish to analyze, the detector that captures the length shifting wave and results, and the element that records the result in graphical form. The spectrometer uses the properties of light to analyze substances.
Okay, now I'm going to talk about the glucometer components. So it is confirmed by test strips, lancets, and a lancet device. The lancets are small pieces of plastic with reactive elements that, when they come into contact with the blood, chemically they react to determine the amount of glucose in the blood. Then there are the lancets, which are puncture devices that are used to facilitate a small extraction of blood. And then there is the lancet device, that as its name says, it's a device that tires or propels the lancet using a button.
Next, we're going to talk about the prototype itself. We have come together, we have come up with a spectrographic glucometer. Basically, it is a digital device that measures the transmittance of a given sample, in this case, blood, to determine the properties of the sample fluid, in this case, blood, and the amount of glucose in it. We made this because the alternative is the strips, which are a lot more costly than a pack of microscope slides, which is what our prototype uses for sampling. We're going to talk about the design and development. The spectrograph itself is made out of Xbox cardboard. You can see it right here. It's been cut out specifically to make it as easy as possible to assemble. It uses IR LEDs or infrared LEDs and photodiodes, in order to come up with a digital read. Photodiodes emit a small amount of electricity when they come in contact with light. There's also the microscope slides where the samples themselves are put in. As mentioned before, they're way cheaper, they're reusable, they're just better alternatives. All of this is hooked up to a Raspberry Pi Pico, which is a microcontroller. The program there allows us to turn those digital readings into percentiles. Next, please. The wiring is very simple. Photodiodes are hooked to the analog to digital pins of the Raspberry Pi Pico. The Pico can read up to 16 bytes, 16 bits of data analogically. We can use up to 20 percentiles, as mentioned before. Next, please. And those percentiles can be used in a companion software we've developed that turns those percentiles into glucose levels, milligrams per deciliter. Not only does this program deduce the amount of glucose in the blood sample, but it also allows us to store it externally in a CSV file or a couple of separated values file, which is a spreadsheet.
Well, now we have the achievement. The Pi Pico, the analyzer itself, is capable of measuring of the transmittance or blood samples, and the program, the accompanying software, can infer the amount of glucose and storing the data externally. Finally, we have the limitations of our project and our prototype. First one, we have a low sample size due to the cost of the testing material. We have interference and inference can be uncomfort. Several communication failures to Windows, and assembly is needed. Well, that is all. Thank you.